Hello, everyone, and welcome to today's webinar. I'm Kevin Henderson, Vice President of Special Projects at LRG Marketing, and I'll be your host. Today's session will be a real treat. It's about airports and how they need to maintain a delicate balance of priorities that include creating a positive traveler experience, optimizing personnel and terminal resources, and maintaining safety and security. The presenters are the same experts that have brought this project to fruition, so there really is no better panel at all to present today. This session will be recorded, so you'll be able to review it and share it with others. We will have time for questions at the end. If you have questions for the presenters, please enter them in the GoToWebinar control box under the Questions tab. Let's get started. Our first presenter is Jason Williams, Director, Innovation and Technology Group at Vancouver Airport Authority. He'll be followed by Gerald Becker, VP of Market Development and Alliances at Quanergy. And then we'll hear from Gary Angel, CEO of Digital Mortar. Jason, the floor is yours.
Thank you, Kevin. It's an absolute pleasure to be joined by such great colleagues here, Gerald and Gary. Really pleased to talk about the work that we've been doing with Quanergy and Digital Mortar. As you can see on screen there, I'm Jason Williams. I'm the Director in our Innovation and Technology Group here with the Vancouver Airport Authority. Specifically, my role is responsible for our software development team. We have our own in-house software development team, and we do a lot of work around developing software and solutions to support our main purpose, which is to move people, planes, bags, and goods every day. The Vancouver Airport Authority sits on the traditional and unceded territory of the Musqueam people, so it's an absolute pleasure to recognize that we get to work and move people every day on Musqueam land. We also exist to serve our community and the economy that supports it. The Vancouver Airport Authority is a non-share capital community-based corporation. As you may have seen, we have also recently won the best airport in North America by Skytrax in 2024, off a little bit of a hiatus during the pandemic, but great to pick these awards back up after having a 12-year streak again from earlier in the decade. Innovation and entrepreneurship is in our DNA, and that's exactly what our team do for the Airport Authority. We have a long history of providing innovative solutions for our airport. One such solution is our Border Express product, which is a border control kiosk. And this product has served us very well at the Vancouver Airport Authority, but it also has served other airports in Canada and around the world as well as a product that we commercialized. We also work to create other software solutions like our digital twin, and I'm going to be pleased to give a demo of our digital twin later in the presentation. But first, I'd like to talk a little bit about the technology that we have put to use from Quanergy and from Digital Mortar, a really great symbiosis of different systems that feed really insightful data of people moving through our airport facilities and feeding that data directly into our digital twin for the benefit of our airport operation. Okay, so just talking about the technology that we've deployed at YVR here, and I want to talk about the fact that we've got 28 LiDAR sensors currently installed in our domestic check-in facility, as well as one of our security screening facilities. So this is the similar sort of facility that you would see with TSA or a CATSA-based security screening facility. This is where passengers are getting screened before they get onto their flights. With the 28 LiDAR sensors, that's obviously seamlessly integrated into Quanergy's Cortex software, and then we have a higher level deployment of Digital Mortar for that seamless data aggregation and business intelligence. We cover a space of about 50,000 square feet, or probably 4,660 square meters. So that's the coverage of the area that we've got in the deployment. The project took roughly 6 months from start to finish, so that includes installing the 28 LiDAR-based sensors, all power over Ethernet, commissioning, and then doing about a month of data validation. And we even did our own data validation, and we're getting accuracies of up to 95% with respect to true passenger counts. The operational tool that we're using is our very own digital twin, and as I mentioned earlier, we'll be giving a demo of that solution. This is a screenshot of the area that we're talking about here. So you can see this is an aerial view of our domestic screening facility. You can see the two major airlines that we support here, being WestJet and Air Canada. And to the top left of the screen there, you can see the PBS pre-board screening domestic south facility where we've deployed the technology as well. This is the pre-board south domestic screening facility, and you can see a shot of where all of the sensors have been deployed. So these are the Quanergy sensors, and you can see we have roughly 11 or 12 sensors on screen there. And then we have this screenshot here of the domestic check-in facility and all of the sensors that we've placed around this particular space. We've also captured a hallway that exists just north of where you can see the two airline check-in facilities there, and this is great for us to really understand when we have long lines that potentially gather in this particular space. So where you can see sensor B1, B2, and B3, sometimes we get lines that extend outside of the security screening facility, and this gives us great insights into the full length of passengers as they may extend into that zone while they're getting the security screening process completed. We chose the Quanergy solution here really due to its ability for scale. As you can see, we've got 28 sensors in this whole deployment, and the Quanergy solution is really good for offering that kind of scale. There's other solutions on the market which would have required nearly hundreds of sensors. So you can imagine hundreds of sensors, hundreds of power over Ethernet runs. The Quanergy solution really did allow us to do this project very, very quickly and get it stood up just as quick as well. So we're very impressed with the speed to deliver a solution. Just got some photos here of what the sensors look like. So you can see there's a couple of different screenshots of where we've got the sensors deployed. As you can see, they're pretty unintrusive. They almost look like surveillance equipment. And we've also come up with our own innovative cover to mask the bracket. So if you want some more information about that, we're more than happy to share our own 3D model that we used to 3D print these covers. Pretty cool. All right, so the real meat and potatoes of the presentation here is really to talk about our digital twin. What is a digital twin? And I've got an extra here from IBM. A digital twin is a virtual representation of an object or system that spans its life cycle, is updated from real-time data, and uses simulation, machine learning, and reasoning to help decision making. And this is a tool that we've been working on since the start of the pandemic. We've deployed it to all of the Vancouver Airport Authority's 1,100 staff. It's predominantly used in our day of operations center, and obviously all staff can use it to augment their particular role in supporting our business. We have guest experience representatives who use the tool as well to understand passenger movements and flow. Our integrated operations center has a bunch of folks that are in there to coordinate various activities. And again, they use this for collaborative decision making around planning resources, both internally and also in talks with folks like CATSA, who do the security screening process, monitoring airline performance, and really just getting an alert of where things could go wrong in the future. So what I'll do is I'll switch to that demo now, and at the end, if anyone has any questions, I'll be pleased to answer them. Okay, so just to describe what you're looking at here, this is a view of our Ops situational awareness tool. This is a tool that has been deployed as part of our digital twin to all of our YVR employees at the airport, and that constitutes about 1,100 folks that have access to this. This is a Windows version of the tool. However, we do have a mobile version of this which runs on iOS devices, so iPads and iPhones, which is a common device that we use here as part of a corporate deployment for all of our employees. So you can see here we have a view of the terminal building, which I can circle there. As we zoom out, you can see the entirety of our airfield. And you can also see all of the aircraft that are departing and arriving. So the aircraft in blue being our departing aircraft, the ones in green being our arriving aircraft. And then you can see a variety of different vehicles that we have on the airfield, be those tow vehicles or ops vehicles, a variety of different types of vehicles that are all using transponders. So this data comes to us from MLAT, which is multilateration, which is a service that NAV Canada provide. We can click on these aircraft and you can see a status of this particular aircraft. This is a 737 MAX. This one is going to IAD, and you can see here that we're estimating 157 passengers on board this particular flight. Something that's also really unique here is we calculate the fuel burn rate of aircraft that we obviously know of. So we know it's a Boeing, we know it's an Air Canada aircraft, so we take a table of the engine types and we calculate based on where this aircraft is in its phase of flight, the amount of fuel that it's burning. And we also look at the timing associated with the journey. So you can see here how much time the aircraft spent at the stand, how much time it spent taxiing, and its overall journey so far. Likewise, we can bring up other aircraft that are arriving. So we'll just click on this one here as an example. We can see this is Porter Airlines. This particular one has come from Toronto, YYZ. And you can see here that we're expecting 101 passengers on that flight. Again, you can see the aircraft type, and we also do that same fuel calculation. And since this was arriving, we can have a look at its stats. We track this from about 3,000 feet, which is our area of interest around the aerodrome. You can see how much time it spent taxiing, 22 seconds on the runway, and how much time it spent on the approach. So this is all great data for us to aggregate across the operation and then measure any operational changes we make. So things like GHG emissions, if we change gating strategies, we can measure the impact of that, measuring the average taxi times and all of those different data elements that are pertinent to the operation. Now, if we move in, we'll have a look at the actual terminal facility here. And this is where this great symbiosis of technology from Digital Mortar and Quanergy have come in to give us really great insights of our passenger processing facility being domestic. What we'll focus on here is our domestic screening facility, so slightly different orientation, but you can see it's the same facility that we have all of our sensors installed. We have a predictive piece where we predict how many passengers are going to come through this facility, and you can see here it's reasonably quiet right now, so that's why there's no alerts. But as we go throughout the day, it gets busier, and again, around lunchtime, which is pretty typical for us right now being summer in Vancouver, we have a big peak of passenger volume coming into the future. We take that data from all of those individual flights. So you saw when I clicked on each of those flights, we predict how many passengers are on each of them, and then we track the schedule of those flights. We calculate the whole passenger journey for all of those flights throughout the day. So all of the domestic flights would be going through this facility. And again, we do the same for international and other areas in the terminal. Since we only have the sensors in this particular facility, we've got this panel here, which is populated with that data. So our raw data from the Quanergy LiDAR sensors feeding into Digital Mortar and then coming through to our digital twin through an API, we can see that we have 34 passengers currently lined up. 3 of the 5 security lanes are open, and that's giving them a wait time of just under 4 minutes here, which is really reasonable for that particular facility. We try and keep our wait times to below 15 minutes. That's our corporate KPI. In this facility here, we also have the check-in facility. So where airlines are checking in, you can see here that for Air Canada domestic, the regular check-in queue currently has 10 people. There are 3 of the 9 available lanes that are serviceable. So that's giving them a 13-minute wait time. Priority, even though they have 3 of the 9 lanes serviceable there's no passengers waiting, so there's no associated wait time for the Air Canada domestic check-in facility. A reasonably good day to be a priority passenger for Air Canada. We can look at WestJet, and here we also don't seem to have too many folks in queue. Their priority one is the top one there, and you can see they've only got one of the 6 lanes open. There's only one person waiting, giving them a 3-minute wait time, and the regular check-in line there, 4 or 5 lanes open, 9 people waiting, so a slightly longer wait time for the WestJet folks. So this is all great data. It's in real time, and it provides a really great insight into the operation to help us move people like guest experience representatives who help passengers go through all of these facilities. Down the bottom here, you can see we have this timeline view of all of the different key facilities that are going to have potential bottlenecks. And again, this is all predictive data that we calculate using machine learning algorithms and the various aggregation of data that we infer from the different flights that are coming in. It's a machine learning model, so we use a bunch of different data sources there, including the Quanergy and digital mortar data to help train and make that model more and more accurate, as we really do need to know exactly when passengers are going to show up and how many of them are going to show up through the different facilities. So I can pick an alert here into the future, and I'll just choose our customs facility so we can go and have a look at a different area of the terminal. And in here you can see here our predicted pax volumes for that particular hour is 500, which is over capacity, in and amongst all of the other alerts that are coming in here for our international arrivals facility. So again, it is very, very busy for us. Red does mean that we're over capacity, but you can see that this is broken down into 15-minute increments. So these short increments of high capacity aren't too concerning for us. However, it will be busy in this facility at those particular times. And again, because this is all tied to flight schedules and live flight data that we get from the status of all of the flights, it's dynamic. So every 3 minutes, we recalculate the model and we represent where we expect passenger movements to be troublesome throughout the day. All right, we can go back to the live view here. What I will do is just show you a couple of other little bits and pieces. So this whole map is all tied to our GIS mapping system. So we can bring in things like information about the rooms. I can just double click on a room here. This is our domestic check-in facility, the size. You can see here that it's public. I can choose another facility here. Let's click on this one. This is Monk's Grill. It's a concession, so it's a restaurant. You can see the size, and you can see it says sterile there, so we know that that's an airside facility. So really great for us to understand where different rooms are and help us search for rooms. If we need to find a room, I can just do that here as well. Just give me a sec. We can search for a room and we can jump to the exact location of that room. So it's a great tool to help our employees find different areas within the terminal. We can turn layers on and off, so we can get rid of all of the passenger screening facilities and passenger processing facilities. You can see this leaves us just with the location of AEDs, or we can layer in the location of wheelchairs. So this is giving us a live view of where all of our wheelchairs are. Again, these wheelchairs are all fitted with GPS transponders, so it's really great for our folks to understand where they all are and where they can be repositioned to help support the operation where we have passengers that require assistance. We can turn that off, and we can layer in elevators and escalators, and the status of those is also displayed in real time here, which is very useful. All right, I just want to move through to another module here that we have, which is our Intelligent Airfield module. This particular module was built, again, during the pandemic when it was very quiet for us at the airport. We took that opportunity to scan the entirety of Sea Island, and including all of the assets. We used a combination of LiDAR techniques with computational vision and photogrammetry to develop this realistic and highly accurate view of the facilities across the campus. So you can see similar data here, but more associated with airside operations. And as I did mention, it is 3D, so I'll just move to that 3D view and you can see that there. You can see here that we also layer in that GIS data and the status of different surfaces. So you can see we have live NOTAM views, notice to airmen. You can see here this particular crosswind runway is not operating as a runway, but it can be used as a taxiway. And you can see here a taxiway that is currently closed. So again, just giving our airside and safety folks some great situational awareness of what's going on out in the airfield. Again, we can look at flights as well. There's a slightly different view of the flights. But again, that same data is present. You can see the type of aircraft, the airline. This one's going to Newark, and you can see here 165 passengers expected on that departing flight. And again, I can click on another flight here. So this particular one from LAX, an Air Canada flight, Boeing 737 MAX. How many passengers we're expecting on that flight, the time, the GHG, and the overall phase of flight that it's in. So really great information to call in from that perspective. Again, because of that layering of GIS data, we can also pull in other information about our runways. So you can see here our north runway, the current wind direction, the wind speed, the operational direction, and the visibility, all in one place. And by comparison, we can go down to our south runway here and have a look at that. Slightly different wind direction, again, the visibility, the operational direction, and the status of key infrastructure on the runway, like the localizer and glide path. Lots of other great metrics are also available here. We can see our on-time journey performance. We can see our average arrival taxi rate. Let me see if I can bring that up. Our average arrival taxi rate there for scheduled flights, for charter flights, cargo and ferry flights. We can see our apron usage for different aprons. All available in one place. And again, we can change the style of the map here. We can make it basic, so a little bit easier on the eyes. We can turn off ground vehicles or air traffic if we wanted to. We can also take it out to an overall view of the airspace around the airfield. So you can see a radar view here of all of the aircraft operating in our area. You can see the ones with question marks are aircraft that aren't necessarily flying into YVR, but all of the ones that have the call signs are aircraft that we know are coming into the Vancouver Airport Authority. And then we can go back to where we began. So that concludes the demo, and I'll just switch back to the slide deck. So as I mentioned, that concludes the demo of our digital twin. It's an absolute pleasure to show it here and also just demonstrate how we've been leveraging the great technology that Quanergy have provided us, as well as that data aggregation system that Digital Mortar provides. We have a ton of other use cases that we're interested in working with both companies with. From a Quanergy perspective, I know that they have some really new and exciting tech on the LiDAR space that we're going to be trialing, as well as expanding our deployment of the Quanergy sensors into other domestic screening facilities that we're currently renovating. On the Digital Mortar side, we know that there's some great tie-ins that they can do to Wi-Fi systems, and that's something that we're going to be looking at doing later in the year, since we have such a mass of Wi-Fi access points across our entire airport campus. There's some great all of campus views that we can potentially work on with Digital Mortar to get that great insight. So we're looking forward to continuing the working relationships that we have with both firms. All right, it is my pleasure now to hand over to Gerald Becker from Quanergy, and thank you so much for this first demo and talk. I'm really excited to take any questions at the end of the program, but Gerald, over to you.
Thanks, Jason. That was great. We appreciate your real-world insights into YVR strategy for flow management within your digital twin deployment. A quick introduction of myself. My name is Gerald Becker, and I am the VP of Market Development and Alliances at Quanergy. My primary focus is developing partnerships, business development, and marketing in the physical security markets to include smart city and smart spaces. So Quanergy is redefining flow management with real-time 3D LiDAR solutions. We're based in Silicon Valley, and Quanergy's revolutionary integrated LiDAR and perception software solution delivers intelligent, proactive awareness for highly dynamic environments like critical infrastructure, smart cities, and smart spaces. Quanergy's mission is to ensure that you see beyond current sensing limitations and experience the power of 3D flow management designed for a 3D world. Quanergy was the first company to offer an end-to-end solution of both hardware and perception software in the LiDAR world. Our combined solution together with sensor and software is called QTrack. Our sensors are NDA compliant, Buy America Act compliant, Trade Agreement Act compliant, GDPR compliant. Our sensors are IP67 rated and can withstand challenging environments. Quanergy LiDARs are the easiest to deploy, offering PoE plus connectivity. The sensor is a Class 1 eye-safe laser, offering 20 times higher accuracy than conventional counting solutions, with zero personal identifiable risk when privacy is a concern. A single sensor can provide 140 meters in diameter of continuous object detection, tracking, and classification. Now let's conceptualize this. We know that 3 American football fields put side by side is about 146 meters. So if we put our sensors next to the football fields, you can see that we can clearly cover the width of them with a single sensor. LiDAR alone does not capture biometric information. In essence, it doesn't see like cameras do. What LiDAR actually captures looks like a 3D silhouette or an outline of moving objects. This provides additional flexibility where cameras would likely not be able to be installed due to either privacy concerns and/or restrictions in the space. The other piece to QTrack is our perception software, Cortex. The easiest way to understand what perception is think of it like a video analytic or an IVA, intelligent video analytic to a camera. Perception is our analytic per se to our LiDAR sensor. It can tell you object types, location, and speed, which we then provide to our partners like Digital Mortar for analytic visualization, which you will see here in a bit. Cortex can track over 1,000 objects simultaneously. It provides centimeter level accuracy. We support Windows. We support Linux. We have an extensive ecosystem of integrations to include various VMSs, PSIMs, cameras, business intelligence, and so much more. Now, it's very important to talk about the TCO advantage of LiDAR versus other counting devices. Our solution is highly scalable and cost effective. In fact, as seen in this airport terminal example, it would likely take anywhere between 60 to 80 plus sensors for people counting to effectively capture this full terminal. Now, let's look at the same terminal example with LiDAR. It's clear to see that we can maximize the coverage, which ultimately brings down the cost across the board for infrastructure, such as your power, your data runs. We bring down the labor costs associated with all the sensor setup and licensing fees associated with the system that you may be deploying at the sensor level. Now, here's an example of deployment we did in Asia. With 12 sensors, we were able to capture the entire terminal. So let's talk a little bit about how LiDAR works and how it can be used at airports. This is a simulation of our sensor. As the unit gets powered up, it begins emitting light pulses in a 360-degree motion in various angles. Now, every time a light pulse hits an object, it leaves a point in the sky up to 1.3 million times per second, which is what we call a point cloud, as seen here. So let's see this in action. I want to give you guys a quick demo of what this actually looks like in real time in my home office. So what you see here is actually 2 sensors in my home office right behind me. Now, the biggest difference between us and what we do versus traditional 2-dimensional cameras or sensors in that regard is that unlike cameras that can only see what's in front of them, you can't see the sides, you can't see top to the bottom or behind. It's not a fisheye or a multi-imager sensor. It's limited to the field of view, whatever the camera can capture, but not with us. So as you can see right here, this is a bird's eye view of my home office. I'm going to do some jumping jacks here so you can see this is all in real time. The sensors are directly behind me, but I can flip this on its side. I can then turn this around, and I'm now looking at myself, looking at my screens, but the sensors are still behind me, right? This is the power of 3D, is that we're able to see this from various angles and different positions that you've never been able to do with other sensors. Now, the power truly starts to come about when you start creating these zones for counting, for tracking, or for whatever the outcome may be. I have some zones I've already developed configured into my system, so I'm going to turn these on. We have the first zone right here, which could be a queue line, maybe at the start of the airport terminal, trying to get in through TSA, CATSA, or maybe another line for whatever it may be. Here's another detection zone, maybe another queue line. And then I created this other one that wraps around my home office. Now, as you can see here, if I enter into the zone, this could provide a counting output to our partners, such as Digital Mortar, that could provide the intelligence to understand how many people are in this zone, how many people are actually in line. If there's too many people in this line, open another queue line at another terminal, or provide signage or details to the guests so that they understand, wait, this place is too backed up, let's go down here, right? This provides all that intelligence through the dashboard capabilities that Digital Mortar will show you here in a bit. But even more so, as I mentioned, This is all in 3D. We can increase the height, we can decrease the height, we could create any number of zones to count, to track, be it for flow management, to count and track objects, be it for security, to track in and out of areas where people should or should not be. This is the power of 3D, right? So with that being said, let's get back into the slides. Quanergy has a strong presence in the aviation market for smart space and security applications. Our solutions are deployed and trusted by the largest international airports around the world. When you look up at digital signs that is guiding you to the next fastest queue or telling you how long the wait is, there's a good chance that a Quanergy sensor is providing that intelligence for you to have a better experience in your travels. In fact, the next time you travel in or out of Vancouver International, on the domestic flight side, make sure to look around. I'm sure you will see Qtrack sensors in the wild. Now, LiDAR can be deployed in various areas at the airport to truly understand the full curb-to-gate journey while maximizing landside and airside operations. Now, starting with parking lots, LiDAR can effectively monitor parking space utilization across properties, which can then tie in directly to real-time counting displays to guide travelers quickly to an open position and allow them to get to the gate faster. At the taxi, bus, and rideshare drop-off pickup zones, we can monitor traffic to measure dwell times, monitor queues, to assist in parking enforcement rules, ultimately to get vehicles in and out of the areas fast and efficiently. At the airline gate check-in counters, we can monitor queue size and general traveler volumes across large spaces to increase flow and maintain proper staffing levels throughout the airline check-in counters. At the airport security check-in lines, we can monitor the size of queues to optimize throughput at the gates. This in turn increases operations flow and provides a proper understanding of required staffing levels throughout the airport terminals in real time. Similarly, queues at boarding gates can be monitored, as you can see here, which in turn can help airlines and ground staff manage boarding processes efficiently and adjust resource dynamically as needed. By mapping customer flow patterns in quick service restaurants and retail, we can provide valuable insights to product placement and throughput to maximize exposure and increase sales opportunities. Albeit we have primarily spoken only about flow management and travel journey optimization, our solutions are deployed at various airports for security-related applications, such as perimeter intrusion detection at fence lines of airports. Our 3D LiDAR solution is able to salute a queue of PTZ camera for precise tracking of potential threats. When the bad actor enters the detection zone, we immediately salute a queue of PTZ camera to then start tracking the person of interest down to the centimeter. You can see that we can track every footstep within Cortex and with the camera as the perpetrator walks along the perimeter. Our sensors are also being implemented in man traps for tracking of people through secure passage areas into sensitive areas. This example would be in a secure area where only one person is allowed through at any given time. As the person badges at the door reader and enters to the secured zone, the sensor sees that no one has followed behind him through the zone that was created in the space. The doors then close up behind him to then open up the doors in front of him and allow him into the secured area, which could then lead into a control room, airside operations, or other zones at the airport. This can prevent any potential breaches and mitigate tailgating by unauthorized person gaining access to a restricted area. Earlier this year, we announced the addition of 2 new sensors to the Qtrack portfolio of products, Qtrack HD and Qtrack Dome. Qtrack LR continues to be our flagship long-range sensor, giving you up to 140 meters of continuous object detection, tracking, and classification, great for flow management and outdoor security applications. Qtrack HD will provide much more laser coverage for high-density environments, such as your queue lines or crowded spaces. This can provide tracking of over 1,000 people continuously within the field of view of the sensor. Qtrack Dome is a great solution for QSR, retail, man traps. This sensor has no blind spots with a 90-degree vertical field of view to capture the whole space in 360. So I'll end on these points. Why Quanergy? First is the total cost of ownership advantage you get with Quanergy by gaining more coverage, replacing anywhere from 5 to 7 sensors with just one LiDAR sensor. 3D LiDAR's total cost of ownership becomes even more advantageous over time. By year 2 and 3, the TCO savings are estimated to be around 70% less than that of 2D systems, making it a highly efficient long-term investment. As I mentioned earlier, just one Q-Track long-range sensor can cover the area equal to 3 football fields, reducing the total cost of equipment needed and significantly cutting the infrastructure and installation and maintenance costs across the board. Next, with Q-Track, you can stitch the sensors together to create a complete digital twin of the airport. Our solution can continuously and uniquely track people throughout your facilities from one scene to the next, improving operational workflows and maximizing operator efficiency with the ultimate goal of providing a great experience for the travelers. Now, when our LiDAR solutions are used for security applications, we are able to reduce the false alarms up to 95% and above. This improves the response and efficiency, avoiding alarm fatigue and ensuring that no real threats get by. Lastly, Quanergy has an extensive ecosystem of technology partners. We work with all major brands of PTZ cameras. We have countless VMS integrations, PSIMs, and business intelligence integrations, which will always continue to expand. With that being said, I want to kick this over to Gary Angel from Digital Mortar to talk about their location analytics platform.
Thanks, Gerald. You know, as I think about the way we're doing this webinar, I think it's kind of backwards because we started with the front end, which is, I admit, the sexy part, and that's probably good journalism. Then we went to the beginning, the foundation of how this stuff works. And now we're going to end with the middle, the plumbing that connects those two things together. So let's talk plumbing. And really to understand what I mean when I talk about plumbing, you have to understand the LiDAR technology stack and how it works. And there are 3 basic components to that stack. The first component is what Gerald just showed you, the LiDAR sensors and the perception software that capture who's moving in an environment and deliver that information to the middleware. And then there's the piece Jason showed you, the really cool part, the sexy part, where you actually get to operationalize all this data and use it effectively. But between those 2 pieces, there's a middleware piece, what we call a people measurement platform, that takes that raw data from the LiDAR system and makes it useful and easy to use for those custom applications that are really going to drive your business. We think of a people measurement platform as having 4 major components. And the first and most basic is foundational. It's called the data processing part of this. And really what the data processing part does is, A, it cleans the data and makes it better. B, it contextualizes the data. It maps it against a digital map of the space. So instead of seeing XY coordinates, you have an understanding of where someone is, the way the business and the customer think about that. And finally, it integrates sources from multiple data sources. So you can take data from Wi-Fi, camera, or LiDAR and put it all together. Above that is the distribution layer. And this is the layer that Jason and his digital twin really take advantage of, because that distribution layer takes all that processed data and makes it available in a seamless and consistent fashion to any kind of custom application that wants to use it. As a part of that, and I break it out separately because it has some special requirements, there's a real-time layer. And the real-time layer is a distribution layer, but it also has user interface components to it as well, and an alerting component that allow you to operationalize your specific requirements around people measurement. And finally, there's a reporting and analytics layer. And not everybody needs to take advantage of that. You saw with what Jason did in the digital twin at YVR, they don't do a lot of reporting and analytics in the people measurement platform. It's available and it's there as a backstop. But if you really want to go full on DIY and build something, you don't have to take advantage of it. Likewise, we see a lot of our customers put data into Tableau or in data lakes and do data science on it. That's all well and good. But it's good to know too that if you just want deep historical reporting and access to the data, it's there right out of the gate with no investment on your part. Now, obviously, you can DIY this whole thing. That's always possible from a software perspective. You can build anything. But a people measurement platform gives you 4 advantages, even if you're a really sophisticated team like Jason runs at YVR. The first one, and I think this is straightforward, it makes it quicker to time to value. By delivering so much functionality underneath the hood, you can really concentrate on just the parts that deliver the most value to the business. And the second thing, and Jason touched upon this just a little bit at the end of his presentation, part of their expansion plans are to add in additional technologies for people measurement. If you're like most airports, what you have is cameras here and maybe some LiDAR there, and then internet and Wi-Fi stuff all over the place. Well, integrating those 3 things together gives you the biggest, broadest picture of people measurement across your entire space. And a people measurement platform allows you to create a single integration point for all of those people measurement sensors and all that data into all of your custom applications. And lastly, and I think anyone who's ever done software development can appreciate this, the more custom stuff you take off the table, the more stuff is pre-built for you when you come to building custom applications and using data, the lower your risk in deploying this kind of application. What a people measurement platform really does is de-risk development around people measurement and flow analytics. So let's drill down a little deeper into each of the layers I talked about. In the data processing layer, both data accuracy and integration are really important, but the step that I think is most unique and interesting is really the mapping layer, where we contextualize the data. Because in the raw data, all you see is, I see an object at XY coordinate, and that's it. But what's really important is understanding what that XY coordinate means. So for instance, when the data shows up in the digital twin, it's looking at things like how many stations are open and how many people are in the queue. But those areas need to be defined. And in our people measurement platform, we give you a really simple, straightforward, but incredibly robust mapping interface where you can say, this is exactly what that XY coordinate means. You can map every single square foot of the space. You can build multiple maps of the space, and you can time date the maps so that they change over time. And as soon as you make a change, it's immediately reflected in the data, and it saves the entire historical record and the maps appropriate to that. Just to give you a sense of how YVR uses this, I took 3 different screenshots of 3 different maps that they use. The first one is basically just the business intelligence view of their space. These are the lounges, this is the flow areas, these are the queue areas, these are the processing areas. This allows them to get all the metrics they want about each business area within the space. But there's a second map that really drives the queue analytics, because queue analytics has a lot of specialized requirements. We need to understand, for instance, what areas are potential overflow areas. Those are areas that aren't traditionally part of the queue, but when the lines overflow, they become part of the queue. And the people measurement platform handles the logic for all that, but it needs to know where all those areas are. And then the third map they use, and I think this one is really interesting because it came from a use case that was developed completely after implementation, is really around HVAC control. You know, air conditioning works differently depending on how many people are in the space. You can actually tune up or tune down your air conditioning based upon occupancy. To do that, all we had to do to support that use case for them was add a whole new map. Those HVAC control zones, they don't correspond to anything related to the business or to queues. They're a completely separate entity. No problem. We build the map, we turn the map on, and instantaneously the HVAC control numbers are available so they can drive HVAC up or down depending on occupancy in those specific zones. Okay, let's talk about the distribution layer a little bit, because this is the part that Jason and his team really use a lot. We take all this information in, we standardize it, we clean it, we integrate it, and then we make it available to your custom applications. And we do that in a really rich variety of ways. There are actually 6 different real-time feeds. That includes feeds around things like line depth and wait times, but it also includes raw data about each event and each classification that we make on the objects coming across. All of those feeds are available to you, all of them are in real time, and all of them are standardized so that your applications can take advantage of them. A lot of times as you build stuff out, you're also going to want to have historical views of the data. So maybe you show somebody what's happening right now, but you also want to show them what's standard for today or what's standard for a Tuesday at 9 a.m. Well, there are 3 different REST API endpoints that allow you to access the data at any level of detail. Every single measurement we capture, at every single mapping level, at any time increment, always available in the REST API for any application that wants to access it. And then finally, for those people who really want to support data science and BI analytics teams, there are 6 out-of-the-box historical data feeds giving you data ranging from every single event we process all the way up to OLAP-style data that's perfect for integration into tools like Tableau. Let's talk about that real-time layer. This is also really fundamental to what you saw in Jason's part of the demo with the digital twin, because underneath the hood, we're taking in that LiDAR data, processing it, cleaning it, deriving things like the queue metrics and the station open metrics, and then providing all of that on a real-time basis. Now, it's great. I think what Jason does is just incredibly awesome. That is one of the slickest UIs and front ends I've ever seen anybody build for this kind of data. But if you don't have that kind of team sophistication, you get a lot of the same power just within the people measurement platform. You can pick up any part of the space and see exactly how it's being used. You see a map of exactly who's traversing it, where they are, and how that's unfolding over time. You get detailed information about every single queue you're monitoring and managing, and you get the built-in alerting function. You can set alerts based on people entering an area, exiting an area, how crowded an area is, how long people have had to wait, what individual dwell times are, what your employees are doing, what the ratio of employees to customers and passengers is, even how fast people are walking through a space. All of those things are alertable, and those alerts can be integrated directly into your system. So this real-time layer is profoundly important to a people measurement platform. And then finally, we take all that data from days and months and years worth, and we provide it back to you in an interface that allows you to access it almost any way you want, from detailed heat maps all the way down to the single square feet to a lot of custom reporting, including the ability to just build your own reports, to get at data all the way down to a 10-minute level for any part of the map you're studying. And because we're tracking people over time, there's also a lot of journey analytics where you can look at how people navigated the space, what they did first, what they did next, and every single path they took through the space. And you can filter that. So you can look at individuals who are premium travelers or TSA travelers or who use the lounge, and you can just see their behavior. And then finally, we give you full forensic analysis where you can load up a day and play it back so you can see exactly what happened in the space. From my perspective, what this is a comprehensive solution for flow analytics that allows you to cover almost any kind of use case. It starts with that LiDAR component, collecting the data, doing it in a PII sensitive fashion, and delivering quality data into our system. And then we map that data, contextualize it, and give you right out of the box all the things you need, plus the ability to really build terrific custom applications on top of that to operationalize the data and take full advantage of it. So whether you need powerful analytics to understand exactly what happened in your space, what's getting used and when it's getting used, or you need real-time visibility to see, hey, are my curbsides right now busy or not? Or you want operational insights about what your employees are doing and how that played out in terms of the overall environment, or you want to build out alerting systems that allow you to dynamically adjust your operations based on what's happening. All that is right out of the box in the people measurement platform, and then you can start customizing on top of that. So in good journalistic practice, I took you through the plumbing part of this, but I also went in a kind of a sexy part of this. And as amazing as I think what YVR did with this data and building a digital twin, they actually still haven't covered all the use cases that are available from this kind of flow analytics data. So I want to step back up and just talk a little bit about the kinds of use cases that you might consider if you're deploying this technology. And that starts with curbside. One of the really nice things about LiDAR is it isn't just a people measurement technology. That's the way we talk about it. But in fact, it was built initially for automotive. It's great at measuring vehicles. It works indoor, it works outdoor. If you want to measure what's happening curbside, set up alerting, understand wait times, and understand crowding, it's a great technology for that. Improving flow through main areas is one of the standard use cases for people. Just understanding how busy things are, where people go, are they getting confused, are they moving in the right ways, and are you over capacity? That's all really important. And of course, in airports, queues are everywhere. Jason really showed off this in terms of what they do with the digital twin. Queue management is fundamental to airports. But what we've seen is a lot of airports have just covered the security, the big main queues. They haven't covered a lot of the secondary areas, but those are still really important to customer journeys. Optimizing queue management around all those things is, I think, one of the biggest opportunities with flow analytics. Delivering better experience with the same labor via dynamic allocation of your people. This is just great business practice. I think it's a force multiplier for your staff, ways to make sure that they're always in the right places at the right time. Improving operations and layout at key usage points. Boy, airports are so complex. There's so many complex operations going on. I think that was really highlighted in what Jason showed with the digital twin. Understanding exactly what's going on really lets you optimize operations on an ongoing basis. Personalizing retail. There's a ton of operations landside retail. That's become really, really important in aviation. This kind of technology is just wonderful for that kind of application. And finally, the data that you collect here, it's going to be really useful to you, but there are a lot of applications to take this data and help your partners, whether those are airline partners or merchant partners, to do a better job with what they're doing. From my perspective, it all boils down to this. I think the future of what you're going to be doing in landside aviation is to measure and optimize every single passenger journey and every attendant operation. And there are so many opportunities to do that, so many opportunities to improve what you do and deliver excellence to the passenger journey. So that's what I've talked about. I think now I'm going to open it up. We're going to go to all three of us and talk a little bit about questions that you guys have. So feel free and fire away.
Thank you, Gary. Thank you, Gary. And I'm going to invite all of the presenters to join the live cameras. So thank you very much. I had an inkling of what was going to be said today, but those presentations were just absolutely fantastic. So thanks to the presenters. We do have some time for questions, and for those of you who are able to stay around a few extra minutes, it looks to me like we have enough questions to go over a little bit. So if you have a few extra minutes, please stand by and stick with us. As a reminder, if you have a question that you'd like to submit to the panel, I got quite a few already, but if you have one that you want to submit, please use the GoToWebinar, the questions tab for capturing that, and that'll make sure that it gets captured correctly. If we aren't able to address all of the questions today, they're still all captured, and I'll forward them to the presenters. They can follow up with you afterward, however is appropriate. So let me see here. Let me start with this one. You know, Jason, this one's going to be for you, Jason. Why did the YVR team invest and go to the great trouble of, I would imagine, in building your own digital twin instead of just purchasing one or having one off the shelf?
That's a great question. And I think for us, we started the journey in late 2020. So, you know, back then when we were assessing what was out there on the market, there wasn't really anything that existed to provide the capabilities of what we were looking to do, which was to have a system of systems that tied into so many different data sources and provided that contextual view and that situational awareness across the airport operation in one application. So we decided we wanted to build it ourselves. We had the in-house team that had the capabilities with our in-house development team. So we took a shot at it. We did an MVP, and here we are a few years later, and it's really grown. And you know, data integration has just gone so vast with the digital twin, and you know, the people movement technology and the Quanergy data is just a small piece of what we're doing there. And I think that sort of was exemplified in the demo.
Great, thank you. Thanks. Gary, this is one I think for you, but it just came in. You were talking about queues and defining the mapping areas for queues, I think. And the question is, how do you track lines that don't really have defined areas? So I think you mentioned overflow areas, and maybe you'd like to elaborate on that a little.
Yeah, so airports are tricky because not only do they have a lot of queues, they have a lot of different kind of queues, right? I mean, there's the giant snake lines, there's the kind of queues that come into ticket counters, there's queues around baggage, there's queues around gates. I think probably the trickiest queues that we deal with are the ones where there's no defined line area. So a lot of times in a gate area, you know, you just line up, the lines go in different directions, they'll snake around the seating areas. They don't develop in the same way every time. That's pretty tricky. The way we actually handle that is what we ask is for you to define the entire area where the queue might be. Now that can extend all the way back into the main terminal passageways. People can be piling through there and not in line at all. The way the software works is once the line starts to form near the stations, or the throughput stations where people are getting checked in, it starts to look at all the people who are in close proximity to that queue, but it also looks at their velocity and direction, because what we find is as those queues extend, what happens is a lot of times they go back into the main terminal passageway. There are people walking through the whole queue area. They're not part of the queue. So part of what it does is it just basically looks for near neighbors and passengers who are waiting there, but they have to fit the pattern of being in that queue. And we found that that's actually a pretty darn accurate way to build those kinds of amorphous queues where you don't have the definition around that. And it's really nice to be able to cover, hey, just about any kind of queue and make sure that you're really getting pretty good results around it.
Fantastic. And I think Jason mentioned the queuing going back into that back hallway. Is that what you guys are doing in that area? Yeah. Oh, fantastic. Okay. Great, great. This may be back for you, Jason. Let me try this with, have you first go at this. Um, because it sounded like the question has to do with people counting, and what are you currently using people counting for? I think you mentioned counting as one of the key functions that you're using, but also this kind of line, even counting in lines, counting people in areas. So are those, can you list off maybe the current use cases for people counting, and then how might you go forward from there?
Yeah, sure. So predominantly it's really around our check-in facility and our pre-board screening facility, which is what was shown in the demo. We want to know how many people are in the space overall. We want to know how many lanes are serviceable for each process point. So whether that be an airline check-in facility or whether that be a security screening facility. And we want to know the length of time people are experiencing in real time while they are going through those processes, because it's very important for us to maintain a high level of service across the traveler's journey when they go through these different processes. But we also use this data to calculate and drive the future learning of our passenger demand model, which is that model that kind of predicts where passengers are going to be throughout the terminal. And having all of that information from the check-in facility is really useful for us to calculate show-up times of when passengers actually show up to the airport. While we do have a general idea of how many passengers we're going to be processing for a day, we don't necessarily know what time they're going to be showing up. So understanding that and getting an accurate reflection of that for future planning as the day progresses is very, very important to the operation. So it does infer a lot of the machine learning that we also implement in the sort of data looking forward.
And Jason, maybe one thing I'll add to that, I think in the way we think about it, there's really two major kinds of people measurement applications, things we call counting and things we call journey. And both are really, really important. The counting applications in airports tend to be around things like queue management, which you guys do extensively, throughput analysis, just understanding occupancy, potentially understanding how many people are in an area and what the usage is, dynamic maintenance, allocation, things like that, where all you're doing is essentially counting how often is something getting used, when is it getting used, and when are those really intensive periods of resource utilization. But it's also important to keep in mind that when you deploy these technologies, as you expand the areas of coverage, you start to track extensive sides of a customer journey, and then you open up new applications where you can start to answer questions about, if a passenger spends this amount of time in a security line, how does it impact the rest of their journey? How many passengers go into retail? Which retail do they go into? How does their journey play out between things like concession and retail and gates? And how does their time get allocated? Those questions are really important too. And I think what we see is a lot of times people start, I think operationally, with the most important stuff, the counting applications that really deliver the core things people need to do to manage what they're doing. And then they start expanding more into the journey stuff, which can really add just a layer of interest and intelligence to this data. And what's cool about it is it's exactly the same system. It's exactly the same sensors and it's exactly the same software. When you've got that stuff deployed, you're getting both kinds of information constantly.
Great, thank you. Thanks for that. Okay, Gerald, I got one for you here. Actually, I got two for you. Let me see if I can combine these. I got two questions. One has to do with the number of sensors. So they're asking, what kind of spaces require more than one? What happens when you need more than one sensor? One sensor has such a long range as you described. But the other question that sort of relates, I think, is that they're asking about whether a LiDAR sensor has been used for the airport exit lane breach control, which I guess is the leaving the sterile area. Right? If you're aware of it ever being used for that, and if that may be one sensor per lane, or I'm not sure how do you determine like one sensor, many sensors? How does that work?
Great question. Don't have a ton of time, but I do want to get the points across. But ultimately, this is at its core, the value of our proposition is the TCO value that you get with our offering, right? A single sensor, I've got one right here. This sensor is going to give you the coverage that potentially 7 sensors would with, like, say, stereoscopic or visual cameras in that regard. That is the core of our value, that we give you so much more visibility with a single sensor. And when it comes down to increasing the area or the map that you're trying to cover, is just a matter of just basically sprinkling in our sensors in the property, and the magic happens within our perception software. As long as the sensors overlap on the laser at the perimeter of the laser coverage, it thinks it's one world. So it continues the journey from one sensor to the next. So instead of a camera where you have to do all kinds of magic and stitching all kinds of different visuals together, it's just a matter of just placing the sensors and they overlap with one another harmoniously. It works perfectly. And then you see, like what I showed you that example, it just looks like one massive digital twin where you see people get dropped off, they go through the terminal, check in and go out, right? So you see all of that play through. And ultimately, you know, a couple of things I want to add to that is, you know, we're not a GPU-based solution. It is CPU-based. You know, Intel is one of our biggest partners. We love what they do with us in partnership into the market, but it comes down to the compute required for these solutions. We only take about 1.5 cores per sensor, about a couple gigs of RAM for the software, and throughput, which is one of the biggest things that nobody talks about when they talk about LiDAR. You know, LiDAR is really cool, but a lot of the other LiDARs that are coming to space are coming from that automotive world or robotics and stuff like that. Our sensors have been purpose-built for flow management and security. We only produce about 15 to 20 megabits of data per second, unlike others that are in the 250, 300, which are just bogging down your network with data, right? It's just boom, boom, boom down your network, right? So this is purpose-built for that, right? So, you know, real quick on your other question regarding man traps and secured areas. So we have a new sensor we've introduced, got it right here. I haven't connected to my network yet, but in essence, this could be in that secured area that gives you a 90-degree vertical field of view up to the horizon in 360. It's kind of like a fishbowl. We're able to see everything and anything in that space. So one sensor can securely track as a person enters and as they exit to eliminate any tailgating, piggyback, or any of that type of nefarious activity that could go from landside to airside or vice versa, right? So try to pack it all in those quick questions, but thank you for that.
There's a lot of information in these presentations and the answers. So let's see. Got a few more. Let me see. Let's Jason. Let me start back with you. You know, the question here is about the benefits that you're getting from using LiDAR versus other kinds of sensors. And I'm going to add to that. Did you always plan to use LiDAR? Was that a decision up front, or was that one that you came to?
Yeah, another great question. I think the benefit with LiDAR is just the pure scalability of it. You know, as you saw in the presentation there, we have, I think, less than 30 sensors covering such a mass terminal footprint, and that really is a big space. If you've ever traveled through the Vancouver airport and seen our domestic check-in facility, it is huge. So just that quantity of sensors and the scalability of it, not just for that particular area, but going into other areas, is a huge advantage. No, we didn't just consider LiDAR. We have worked with some other solutions. So stereoscopic vendor, I'm sure everyone knows what I'm talking about. We use some of their technology as well, just to compare and experiment with the different areas where that could be more beneficial. Certainly for doorways and things like that, we've found the stereoscopic sensors work quite well. The next sort of iteration of what we're going into is CCTV. Biggest challenge with us with CCTV is, you know, we've got thousands of cameras, but it's all on-prem. We can't use cloud-based systems to process CCTV footage just because of the security and safety and privacy concerns around that. But we are looking to potentially experiment with some on-prem solutions and edge device-based solutions. And there was one other one that I was going to mention, but it's obviously not important enough, so we won't go there.
we can always come back to you.
Oh, sorry, no, it is. It's actually very important. Sorry, and I think I mentioned it in the presentation. It's to do with digital mortar and their capability of tying into Wi-Fi access points. We are looking at potentially doing, you know, a whole sort of airport campus-wide sort of iteration of this by using our existing Wi-Fi. Certainly not going to be as accurate, but definitely something for us to experiment with and trial. So Gary and I have talked about that offline, but we're going to hopefully pull the trigger on that soon, Gary.
No, that's cool. And we work with a variety of technologies, and each technology has some things it does extraordinarily well. But I think what we find is that for a lot of these large scale spaces, LiDAR is just the best fit. It's so flexible from an environmental perspective. Gerald touched on this a little bit. It's really easy to deploy. If you're used to lining up cameras in very tight formations and having a tremendous number of them in the ceiling, this is going to feel like heaven to you when you deploy it. It's just a lot easier from that perspective. But I think from our perspective, yeah, you can get things out of electronics you cannot get out of camera or LiDAR, but boy, it's missing a ton. And camera and LiDAR are very similar in what they provide, but the LiDAR just gives you the scale, and particularly for airports where the spaces are huge, the ceilings are complex, the ability to deploy easily and seamlessly with a relatively small number of sensors, it's just really nice for this environment.
Great, great, great. Thank you. Gary, let me stick with you for a minute with this one. See, the question is, I don't have a dedicated engineering team like Jason team there. How would you recommend getting started with, a smaller, more modest, first step on a project like this?
Yeah, I was blown away when I saw what Jason did. It's incredible. It really is an awesome system. And I mean, I would have hesitated to build something like that. I think that is a incredibly robust system, beautiful interface, and with a tremendous number of integrations with it. So I think most people are probably in a boat where looking at something like that is pretty damn intimidating. One of the nice things about people measurement, though, is hey, you can start with very discrete projects that are relatively easy to deploy. So if you target some of the key use cases that Gerald and I and Jason all talked about, whether it's queue management, whether it's curbside, maybe you target your busiest curbsides. You put a couple LiDAR sensors in and you target just that application with a people measurement platform. You can do most of what you need to do without any additional customization on top of that. So I think what I would say for people who don't have the really rich, internal resources and IT teams is don't try to do the whole thing. Try to pick off some of the core applications that are really easy, turnkey, and deliverable out of the core solutions and target those. And I think that's a really viable strategy for getting started and actually going quite a long ways down the people measurement road.
To be honest, that's exactly how we started with Jason. It started off with a man trap, and here we are doing a full-on terminal-wide deployment. So start little by little, and it gets to where you need it to be.
Fantastic, fantastic, good advice. Okay, Gerald, let me stick with you. I've got two questions here that look to be related. So I think you mentioned that you hinted at this at one of your previous answers too. What kind of computer power do I have to handle that huge data that's coming from your sensors? And then a related question was, can a customer use their own servers? And I'm wondering if that was for the processing. Sort of, is it a choice of local server versus cloud, or is it just servers for your processing versus like what Gary was talking about and what Jason's talking about? How do I draw those lines?
There's a lot to unpack there, but I'm going to try to just summarize it real quick. So as I mentioned earlier, a single sensor is about a core and a half per sensor to compute. It takes only about 2 gigs of RAM on the perception. That's on a per sensor. You can virtualize this as well, and we scale horizontally. So you add more compute, you could throw more sensors into your deployment and scale potentially infinitely if you decided and you had the budget. So as far as the deployment goes, once again, it's pretty robust in the sense as far as how we can architect this. It could be on-prem, it could be in the cloud, it could be hybrid. We've done several deployments with Gary where it was a hybrid deployment where we have our sensors going to a NUC or to some sort of server for pre-processing, then it pushes directly to Gary's platform in his cloud instance to do the massaging of the metadata that he's getting inputted through our sensors, right? Or it could be completely on-prem. So we're really open and we support both Windows, Linux, and it's highly scalable. As you've seen with the presentation, it's quite open to fit quite a bit of different type of complexities and architectures.
So I think what I'm hearing is it's less than people might think it needs, and that you can do it on-prem with your own servers or expand to whatever level you're looking for. Okay, that's what I was looking for.
Absolutely, we're not proprietary to servers either, right? So if our end customers, our channel partners, technology partners want to go ahead and create their own server instance, as long as they're taking our our specs to build their server instances, great, go for it. You know, we also have vendors that we love to work with and provide you know, a turnkey solution for if it's a 4, 8, 20, or 1,000 sensor deployment. We can provide that as well.
Yeah, and I ditto all of that. Jason's team, as you probably expect, runs on-prem, and that's I think a lot of aviation users are probably going to be in the same thing. But you can also, and this goes back maybe to the, hey, I want an easy place to get started. Well, one easy way to get started is to let it run in the cloud and do a specific application, and that's a very viable deployment model too. So it's very flexible from that perspective. You just want to get started easy in the cloud and do something really small without a lot of IT implications. That's possible. You want to run it all internally and do it entirely on-prem. That's definitely possible as well.
Okay, Jason, back to you. I'm going to combine two again. So is this project so far addressing the pain points that you were hoping to address? And what's next? What's next for you on your digital twin journey?
Yeah, I think you know, the validation step and getting the sensors installed and you know, trusting the data was a big journey for us, just from a trust perspective, and I'm so pleased that we've definitely reached that milestone. So our operations folks are using this data in real time. It means that they don't have to go manually check. They can just rely on the data that they're looking at on screen, which is fantastic. So it's been a huge win from that perspective. The learning that we're getting from the data as well to inform, you know, the future plan of the operational day is also incredibly beneficial. As far as where we go next, we are expanding the LiDAR solution into a new pre-board screening facility it's not really new, it's just getting renovated. So we're adding another 15 or 20 LiDAR sensors there, which are also going to pick up some of the overflow and some of the areas where we have international check-in for Air Canada. So, so looking forward to bringing that online. But maybe a more bigger picture as far as the digital twin is concerned, we're obviously going to keep investing in the technology. We're going to keep growing the capabilities, keep growing the integrations that we have. The next big thing for us is really to look at simulation and how simulation could also help infer the operational day and the plan ahead and what's to come, and perhaps, you know, give us much better early indicators of where things may need to be adjusted, and if they don't get adjusted, the impact of not, you know, having that adjustment made. And then also looking at cargo. You know, I mentioned the important thing for YVR is to move people, planes, bags, and cargo. Cargo is such an important element of our business. We're obviously going to start working in that space, and potentially employ things like LiDAR-based solutions for, you know, tracking cargo, and, you know, all of the above. So lots more to come in that space.
Fascinating, fascinating. Okay, so how do they get a demo? What do you think, Gerald?
Yeah, if you could put up our contact slide real quick. This is super easy. Yeah, so you could definitely get a hold of Gary or myself directly. Also find us directly on LinkedIn if you haven't connected with us. Love to connect with you. You've got our emails and direct phone numbers for both Gary and myself. We left Jason's LinkedIn just so we don't bog him down with contacts. But either way, if you want a demonstration, you want to talk a little bit more in detail about the solution, both on the BI side or the sensors side, give us a call, send us an email. We'll set up a follow-up call with you guys. And you know, we really do appreciate everybody who took the time to go a little bit over on the calendar, but even more so to learn about, you know, this fascinating technology and how YVR is deploying this at scale.
Wow. Well, I know we're just about at the end of the webinar today. Huge thank you to all three of you. And thank you so much, Jason, for sharing your experiences and you know, being so open about what you're trying to achieve and how far you've come. Really appreciate it, and it brings it into a lot of reality for many of us. So big thank you. Big thank you to all of you too for joining us. We really appreciate it, and please follow up with those guys as Gerald had mentioned. We take note of that contact info. And we hope you just be safe and enjoy the rest of your day. Thank you so much for taking the time with us. Okay, bye-bye for now.
Thanks, everybody.